Welcome back to the Daily Grind. This is episode 3. We're going with Leading by Example, broadcasting live from, again, the EV garage here at Lafayette College in Easton, Pennsylvania. A big thanks to the EV Club for letting me use their space once again. The machine shop's going to be pretty busy here soon, so we don't want to crowd them and be without them. Remember, if you have a high school age child looking for a college, Lafayette College offers an unparalleled hands-on engineering education that will put you ahead of the pack. So I ask you to say Kernon or why not and apply to Lafayette. This is your first time joining us. Welcome. This is an informal chat about machine shops and machine shop culture over a cup of coffee. It's the Daily Grind. I'd like to thank Lafayette Engineering for providing the swag. And today's cup is Strange Animal by Blackout Coffee Company. So thank you to them. I bought it, so it's not really like they gave it to me, but it is delicious. Now, as an added bonus, at the end of today's interview, there will be another video of a pre-recorded talk with Dr. Jeff Helm, Associate Professor of Mechanical Engineering, about a tandem part of the talk we're going to have today. As to today, I have a Mr. Taylor Alger, and if I hack this up, Taylor, please correct me, process manager or project manager for process improvement.
That's correct, the second one.
Let's make our first cut of the day. Thank you for joining us. I want to extend my thanks on behalf of Cutting Tool Engineering and Lafayette, your alma mater, for coming to us today. So let's dig right in. I gave you a bunch of questions ahead of time that I wanted to talk over with you today. Let's go over them again. I asked you to give us a small background, brief background about your past, how you became an engineer, what made you want to become an engineer, and what brought you specifically to Lafayette. So please, lead the way.
Sure. So I'm one of the lucky ones that kind of knew what I wanted to do right from the start. I knew I wanted to be a mechanical engineer. I grew up taking things apart, building things, lawnmowers, snowmobiles, anything I could get my hands on. In high school, I rebuilt an old snowmobile with the help of a forum and YouTube. And I was really lucky that I had parents that supported it growing up, kind of my interest in all things mechanical. But then, when I was touring schools, I remember visiting Lafayette and actually being really excited about the machine shop just because it was kind of exactly what I had envisioned, just a neat shop space with a lot of, lathes, mills, water jet, CNC, everything that I had seen on the TV shows on the Prime History Channel and Discovery Channel days that I loved so much. And then when I graduated, I worked for my first 5 years as a process engineer for manufacturing companies. And then recently made the switch over, 2 years ago, made the switch over to project management for process improvements with a pharmaceutical company. So I was in the machining area for about 3 to 4 years. I've since jumped out, but I loved the machining stuff.
So you had almost a lifelong mechanical aptitude that brought you down this path. You gave us your background before you became an engineer. Now that you've become an engineer, what is your background in working with a shop specifically?
I'll say my first shop experience was actually at a neighbor's house. I was working on a project. I was trying to rebuild a dolly, and I had lost a pin for it. And he was the guy you go see for everything. And I went to his house and I showed him what was wrong. And we went into his barn and he showed me his lathe, and I had never seen one before. And he machined a new pin for me, and it absolutely made my jaw drop. I was really excited about it, learning what machining was, seeing it, and then it got me excited enough to go find my own lathe, a small Atlas lathe. No, it was a Craftsman. I ended up rebuilding it.
Was that the one you were rebuilding while you were here, that Atlas?
Let's see. Well, I had two. I bought a Craftsman 109. It was about this big. And then I had an Atlas that I was rebuilding towards the later part of high school. But yeah, that was my first shop experience, if you will. And then my first ever real shop experience, I would say, like in a machine shop, was at Lafayette in ME210. And then the summer after sophomore year, I was able to, in an internship I did some simple machining on a manual lathe then in Bridgeport, just basic operations, making fixtures and tool and test fixtures and whatnot. Nothing too exciting though. No threading or boring, just kind of turning and facing, cleaning off parts and drilling holes.
So you had, so we were some of your first real experience, which we're thankful for. But you have, so you played in garage shops and did things outside of just your college years here, and then before you went on to your career. What advice can you give to up and coming engineers and even veteran engineers, plus shop staff?
I think the most important thing, and I've seen this time and time again, is don't work in silos. Reach across professions, understand what everybody does. Everybody has something to contribute. So, like when I was a process engineer, I like to think I had a really good relationship with our design engineers, machine operators, machinists, material handlers, maintenance staff. Just understand what everybody does. Everybody's there for a reason, and they all have something to offer. And it's, you work together to make a product or to make the business run. And, explain what you do as well. Help them understand what makes your job easier, what makes their job easier, what's important to every different stakeholder. For example, like with design engineers, explain the cost of tolerance, explain, a lot of them know that, right? But like the seeing is believing, understanding how we make the part, what the implications of certain design features are, suggesting alternatives. Maybe if you have like a turned feature with two different radii on the outside, so can these two be the same radii so that we can use one tool, something like that. Let's see. So with machine operators, understand, I think that they want to come to work every day and do a good job. They don't want to run scrap. Make their job easier, understand what makes their job hard. They have a lot of anecdotal information like, oh, this machine runs this part number better, or this machine runs that part number better. Understand what that might be. Sometimes it might just be anecdotal, if you will, but then, follow it with data, look into it for them, understand what's going on, and you can actually discover a lot of things that you're surprised about, just understanding what they go through every day. I think, especially for machine operators, a lot of people default to training, like, oh, we ran scrap because we need to do better training, or something along those lines. But look to take the mentality of our process failed them for one reason or another. I mean, sometimes you have a bad day at work, right? But and things happen. But look at it as, how can I get rid of the opportunity for this mistake anytime it's made? And one of my favorite things we ever did was the most simple thing. We had a laser engraving process to mark part numbers, and a new machine operator put parts in our laser wrong, and we had to scrap the whole batch because they were mislabeled. And we talked about it and thought that training was a good solution, but when we challenged it and we found out we could actually just put a stick in the laser so that you couldn't put the parts in wrong anymore, the problem went away and we never had to worry about training again. And those are the kind of things that are important, is always taking an extra step to make things better. And then the other thing that would be important for engineers is to always use, to the best of your abilities, use data to make decisions. You can argue with data, but it's common ground, if you will, for having discussion. It gets rid of a lot of opinions and speculation, and it really helps formulate corrective actions and problem solving, but also know when you have good data and how to get good data, because that's a really important thing too, is data integrity. Making decisions on bad data is a bad idea, and it'll just lead you to chasing your tail.
Toward the end, we talked about the elephant in the room, and that is AI in design and AI in manufacturing. You've expressed your opinions on it. I don't know if I necessarily agree with having it be such a big part of manufacturing. That said, it's coming, and I'll let you take over. Please touch on that. We had a pretty good talk about this.
Yeah, I think that no matter what people's feelings are on it, I think it's coming and it's here to stay. If it isn't already, I use it every day in work, not for manufacturing or anything like that, but for making my own job easier and to make myself more efficient. But the things that AI will be capable of in manufacturing are just, we probably don't even know yet. But just thinking through like the end-to-end analysis it'll be able to do, all the way from raw material to finished goods, and predictive analytics, and looking at all of the data that companies collect that we can start to leverage with it. I mean, it's scary. It's a disruptor, but I think that we need to take the mentality of how are we going to work with it? What new jobs is this going to create? What new roles in our jobs? I mean, there are things that we're going to be doing that we don't even understand yet, as we learn how to work with it.
I guess you could say anything new is scary. I'm sure that some of the old guard that worked with older type tooling was afraid of carbide or afraid of NC machines taking off as fast as they did. But I'll quote Dr. Brent Utter, professor or an associate professor of mechanical engineering here, when he said he's a Luddite or a Luddite. I don't know exactly the pronunciation, but very skeptical of AI, and I think the term is really misused a lot. The way we discussed it in our talks, and it was just a passive talk, was if you're familiar with, and I forget who talked to it with me, or talked about it with me, but the students were using the AI feature in Inventor and Fusion to come up with the suspension geometry. And Dr. Utter plainly told me that it's not really AI, is generative design. It took things that worked and got rid of things that didn't. And it wasn't really taking input to create the geometry. So I think that's where my skepticism comes from. And just the typical thing. You don't want to be replaced by a computer or a robot. But so be it. I guess I am a bit of a Luddite when it comes to AI myself. I am afraid of it. I do fear it. I do have a lot of skepticisms of it. But like you plainly laid out, it's the elephant in the room, and it's not going anywhere.
Yeah, I like two thoughts on that would be, I mean, the first is it's not perfect yet. Certainly it's getting better every day, but the value of it is, I mean, you can't, it's going to be world changing, excuse me. But I think that you still have to audit it and respect it and understand what you're asking of it, and to be able to gut check with it. Does that make sense? Estimate how much this weighs or how long this will take, and just know from your own experiences and good engineering judgment, does that make sense? I mean, use it to lead you down the correct path. Don't necessarily take everything it says for total knowledge, if you will. But then the other thing about change, and change is scary. And my thought on that though is we have to embrace it, because every company giant that's never embraced change, they're the ones that end up not doing so well. Look at Blockbuster, for example. They didn't embrace the digital age of film and streaming, and they're a thing of the past. They're an overnight giant shut down. So it is very scary. Don't get me wrong. There's a lot of things being thrown around about all the jobs that'll be lost from AI, but there's a whole new world waiting to be created with it, most likely.
So, I'm sure you remember him from your time here, my coworker, Adam Smith.
Yes,
So
engineering
he's
technician,
very
right?
important that I pair it to anybody that will listen, and that becomes is seeming to become a lesser and lesser number. I asked my wife. Is AI is only as good as the information we give to it. So if somebody puts in butt terrible information, you're going to get crap back out. Do you agree?
Yeah, I remember seeing an article like a year ago that said in its first few months with humans, we've made ChatGPT dumber. But yeah, it's like anything. It's That's why it's important to have judgment when you get the answer from it. Does it make sense? Can you trust it? Take everything with a grain of salt.
Thank you, Taylor. I want to thank you again for taking the time to sit down with us and share all this really, really great information for those listening and watching. Uh, that brings us to the end of today's live interview. I want to thank you all for watching and listening. Again, thank you, Taylor, for taking the time. Um, Next week, same time, same place, with our first live in person guest, Dr. Rohan Prabhu, PhD. He will be discussing, or him and I will be discussing, a very, very, very big topic that we both feel strongly about iterative design and where all of those old designs get to, called the graveyard of ideas. And just like this week, next week we'll also have another pre-recorded interview that I'm going to broadcast live right after the live interview with Kat Valentine, the director of the Makerspace at my alma mater, Penn College of Technology. I've talked about them many times in the past. She steals the show with her advocacy for makerspaces and what they can do to help shape the future of manufacturing's leaders. So please, again, tune in next week, 8 a.m. Eastern, live for this show, The Daily Grind, presented by Cutting Tool Engineering, hosted and broadcasted live from Lafayette College in Easton, Pennsylvania. I want to thank everybody. Also, I hope you had a really great Thanksgiving. So I am on LinkedIn. I would love to hear your opinions and your thoughts on this week's show. I am looking forward to speaking with you all again next week. Bye-bye. Thanks, Taylor.
Thank you for having me.
I'd like to start out with every guest that I'm going to have. If you could please give a brief backstory. What is your education, any prior experience joining Lafayette, and what specifically brought you to Lafayette?
Well, I'm Jeff Helm. I'm a associate professor at Lafayette College in the mechanical engineering department. Like all good mechanical engineers, I have a degree in theater. So that is a bit of an unusual background story. But I will say, not as unusual as people think. The technical side of theater is really a hands-on engineering project just done with a little less math and probably a smaller time frame than most bigger engineering projects. But that's sort of how I got going. At some point, decided it was time to go back to school and get a degree in engineering. And I did that at the University of South Carolina. And from there, I did graduate research also at the University of South Carolina with NASA. And we're develop a method called digital image correlation. So if you take a piece, something like this, that's got these speckles on it, they're just random speckles. But if you observe it with two cameras, and then I can twist it, well, the method we developed is that you can track how the surface changed when you did that. And I was one of the first people to make that work in three-dimensional space. And that's been used in everything from tires to proofing components that have gone to the International Space Station.
Wow, so you have your little signature on stuff at the International Space Station.
There's a couple of components that went up because and we weren't the only ones to say that they were flight ready, but we did actually help in making sure that they were indeed flight ready. Most of the work I did was actually looking at the outside of commercial aircraft. The exterior of commercial aircraft back from the 60s and 70s was made with an aluminum called 2024 T3. and it's one that does age. And there was a difficulty with a flight out of Hawaii um, back in the mid 80s. And basically, a whole big chunk of the roof of the plane pulled off.
Ooh.
And yes, Boeing was not expecting to make a convertible, but that's in essence what it turned out to be. Um, and our job was to try to figure out why it happened. And lots and lots of people were involved in it, but my job was to be able to measure how the surfaces moved when it was under loading so that we could figure out how the loads were getting transmitted to the crack tips. And we were investigating something called multi-site fatigue damage. So that was what I was doing as my graduate work. And we actually did develop this and sold it commercially as a system before I came to Lafayette.
Wow. So this system that you worked on, is it also the system that you helped Dr. Manti with his professional research?
Yeah, so when I left, I kept working on developing the method. And one of the neat things is that basically it's a ruler, if you can think of it that way. It's a way of measuring how the surface moves. And what makes that fun is because I need to measure something. And so I got to play with lots of people over the years. So the latest was I was working with Dr. Manti to work on bridge structures and how they deform when they would get put under load because were trying to, once again, prove out a particular joint for bridges so they can be used for bridge construction or more importantly, repair. I've worked with Dr. Kurtz in the civil engineering. We looked at large panels of concrete that were reinforced with carbon fiber. And we were able to take measurements with that. Worked with Mohamed Suleiman, also from the civil engineering, where
Yes, I
we
remember.
looked at surfaces of sand moving around. So if you have something that moves and you want to measure it to a high degree of accuracy, um, that's what you use this kind of system for.
Very cool. Now, I on point two, or my next question is a two-part question. So part A is, in all of your years of instruction here at Lafayette, what have you found to be the best practices to teach up and coming mechanical engineers on how to best interact with a machine shop they may have access to, whether it be in-house or a vendor?
Well, the easiest way to make it work is to make them have to do something.
Oh,
So, I
like
mean,
force a problem in front of them.
yeah, and it's and also to make sure that they have. So this is. I remember you talked a little bit about our ME 210 class, our manufacturing and design,
Yes.
and that is really one of the big things I hope the students get from it is that we teach them a lot about design, how to make good choices, but we're giving them a problem we know they don't have the ability to truly solve. And part of that is working in the machine shop. In the number of students that have had prior experience with the machine shop is getting smaller and smaller. And so when the students go in to actually build their little cars, they really have very little experience other than the project we already taught them before. And one of the things that we really try to bring out in the class is that if you learn how to work with the technical people that are around you, with the technicians, that they are very smart people that know what they're doing. And one of the mistakes you can make as a young engineer is to go in thinking that because you're an engineer, you know everything. And now that they have an experience, they know that the people they're working with are going to be smart. They can ask them questions without it seeming like somehow they're less of an engineer because you're asking the technician a question. And that really can help them in the world when they get out there because they know that they can depend upon other people and know how important those other people will be to them if they're doing something that's going to require some kind of machining.
Thank you. And the final point, the final part of the question that I will ask today is a colleague of ours, Dr. Brent Utter, pointed out a very good suggestion that it would be very beneficial for anybody teaching the next generations to lead by example. In that any professor or any instructor that's going to teach the next generation should come from a background of actually spending time at the machines to make their parts or design or make some of their research designs. Is that something you would agree with, or is there anything you would add to that?
I mean, I think it would be good, but I also, once again, acknowledging the fact that the hands-on aspect of things has not been taught as much in the last 20 years. I do think it might be harder to find. So now what you've got to look for is the people that would be willing to learn as they are teaching. I think it's going to be harder to find people who step into the job that are going to already have this experience, particularly if you're picking them up shortly after they're out of graduate school, which is fairly typical at Lafayette. Um, Therefore, what you need to do is find someone who says, I'm not going to mind going and learning how this stuff works, so that I can pass that on to the students.
Thank you. So that is everything I wanted to touch on today. I want to thank you again very much for taking the time to sit down with us and share with the audience. As an announcement, Dr. Helm will be retiring from Lafayette in December. And I'd like to take a moment to speak for everybody and say that Acopian is really going to miss you. You have really, really big shoes to fill. And this last little tidbit of advice you gave before you go on to riding off into the sunset is very helpful. So thank you very much for your time.
No, thanks for having me, Rob. I've really enjoyed working with everyone at Lafayette, but I've got to say just once again that the technicians are really what make ME210 work, because you've always accepted the educational side of your job, which is not necessarily in the job description. And that really, really makes a difference when the students feel like there's someone there that is going to help them and going to show them what they need to do, rather than just someone who's going to be waiting for prints and orders, and you'll do exactly what they say.
Thank you for the kind words, Doc. Once again, thank you very much for your time. And I think that does it.